In this question, it's really important that you visualize what's happening in this situation. So the arrow is being shot straight up in the air, and so as soon as the arrow leaves the bow, you need to think of it as there's no other force acting on it except gravity once the bow is released. And so the arrow is actually going to slow down until it reaches its maximum height. And when it reaches its maximum height, that's that turnaround point that we talk about. And so at the very top, we would say it's going to turn around. So therefore, the final velocity would be 0. So it would start here, and it would have its initial velocity, which is going to be 80 meters per second. It's going to get shot. The reason it's moving 80 meters per second is because of the bow, and it gets shot and released, and it's going to go straight up until it gets to its very top, and then at that point its final velocity is going to be 0. And then we also know acceleration to gravity is going to be negative 9.8 meters per second squared. So that's information. Like, as soon as we get this free fall scenario, so even though there is a mechanism that's going to shoot the arrow up, as soon as it leaves that mechanism, much like as soon as the ball leaves your hand, the only force that's acting on it is gravity. And when it reaches its maximum height, you can always assume that it's going to have a final velocity of 0 in a one-dimensional motion. So this is when it's going straight up and straight back down. So because of that, then we can figure out how long it's going to take, because now we can take our acceleration equation. We know our final velocity, we know our initial velocity, and we know our acceleration, because that is the acceleration due to gravity. So now we have negative 80 divided by our negative 9.8, and so our time to the top is going to be 8.16 seconds. Now, we assume in these kind of questions that there is minimal or to no friction involved. So the time to get to the top, right, if that was the peak, is going to be half the amount of time that it takes to complete the whole trip going up and down. So really we're taking our 8.16 and we're going to multiply it by 2. It takes 8.16 seconds to move up to the top, and then 8.16 seconds to come back down to the bottom. So you can assume that the time it takes to get to the peak is the same amount of time that it takes to get to the bottom. That is really to do with the law of conservation of energy, which is something that we'll focus more on when we get into that energy unit.